So let's say the interactions variable. So it will be better if we just start this and try to understand this concept of this interactions variable through these tags. Suppose let's in these tags we have those four features of particular data sets. The features is height, height, weight, hair length, and hair length, height, weight, hair length, and eye color. And these things, these features are in general we have seen we call it xi, and corresponding output is the gender, that is y. So the first example that if suppose we have a specific problem, based on this problem we need such kind of requirement. Means if our height is less than 150 centimeter and weight is less than 60 kgs, if such kind of features we needed. So these kind of interactions between two features, it is the features, one kind of features it is, and it is also one kind of features. Means we have interact between these two features using this logical operator and based on these total features we have got some output. So this kind of interactions between two features are called the logical two-way interaction features. So this logical is responsible for we have using here logical operator. Two-way is responsible for we have used here these two features and interaction. Because of these reasons, this kind of feature interactions is called the logical two-way interaction features. Now let's try to understand through this example. Here we have using these two features. Suppose in a specific problem, in a specific requirement, we need such kind of height into weight, height or height into root over of weight. If such kind of problem we require such kind of interactions, then this kind of interaction is called the mathematical two-way interaction features. Why? Since these two features, just see it, these two features H and W are the two features and it's interacted by using the simple mathematical operator. Because of these reasons, these things are called the mathematical two-way interaction features. Now let's see through these third examples. Suppose we have for a particular problem we require such kind of interaction. So here we have taken three features: height, weight, as well hair length. So in such scenario, let's see in such scenario, we have some specific threshold for height, specific threshold for weight, and also specific threshold for hair length, and we have interacted between each features by using the logical operator. Because of this reason, this kind of interaction feature is called the logical three-way interaction features. Okay, so now the question is how we'll find the correct threshold value and what kind of interactions we needed. It depends on the problem to problem, task to task. But in general, it's applied a simpler decision tree. Okay, so when we discuss the case study, various of case study, then we got the point how these things are applicable on real world. Okay, now let's try to now suppose the questions that how we'll find a good interaction feature by simply using the concept of the decision. Suppose the data set we have taken here like that, and it is the output corresponding edge features. These things are called the xi or yi's. So if we apply decision tree onto this data set, then we suppose let we got this kind of decision tree. So first, if our height is less than 150 centimeter, then there have two threshold value. Then if yes, then we got this threshold value. If weight is less than 65 centimeter, if no, you got the weight is less greater than 80 kgs. Sorry, it is if yes, then we got weight is less than 65 kgs. If no, you get than 80. Then also for this branch, you got yes or no. If it is yes, then y is equals to 0. If it is no, y is equals to 1. Similarly as well here also. Okay, so just see this path. If you see this white path, then we got if height is less than 150 centimeter and weight is less than 65 centimeter, then we got the output yi is equals to 0. If we take this yellow path, then we can conclude that if we take this feature's height less than 150 centimeter and if we got weight is greater than is equals to 65 centimeter, then y is equals to 1. Similarly as well here also this path, we can conclude this kind of interactions. These are the logical interactions. So it depends on the how much uh, how many way you have want to take, it's depend on the depth of the decision tree. Okay, and its threshold value also depend on the this threshold value, the each node. I think you got the point. So when we discuss the case study, then we'll see how much importance it is in real world data. I think from these discussions you got the idea what is the interaction variable, and how we'll build this kind of interaction by simply using the logical operator. So it's the general purpose. Not always we have applied the decision tree on to build its interactions. So it's depend on the problem to problem, domain to domain. It's based on the expert knowledge, domain expert knowledge. We have to create these interactions. Okay, we will see in case study how these things are applicable when we discuss the case study.